I know it's hard when sort of a lesson is split over 2 days because we have to kind of take some time to remember what we were doing, but in some ways there's some benefits in that you see it on a couple different days. You're going to learn it better because of that. This is why you should be doing some studying at home outside of class because you see it a second time. But we were solving equations with unrelated bases, as in things like 2 and 43, or any numbers like that that aren't whole number powers of the same base. You can use logarithms to do that. You can use logarithms base 10 because then you can just use your calculator. So this was how we ended up solving this here, right? If you take the logarithm of both sides, then you can use the power rule to move this over there. And you can divide, you turn it into a linear equation then basically, right? It was an exponential equation. You write an equivalent linear equation that you can solve like that, get the number, and that's what we do, right? You hopefully tried to do that with this one. The only difference here is that this says 5x, not x. So hopefully when you solve that, if the variable is in the exponent, take the logarithm of both sides, log of 3 to the 5x equals log of 600. I guess if we were doing a good job of this, we should line up the equal signs, but remove that. And then the key is power rule says that can go down there. That's what allows you to kind of get at the exponent, turn it into a linear equation. 5x log 3. You actually don't need to bring the 5 down. What you can do is you could just bring the x down if you really wanted to, because 3 to the 5x is the same as 3 to the 5 to the x. Okay? If you guys are talking, do you want to stop, please, whoever that is? What you can do is bring the x down if you want. I'm going to bring the entire exponent down because I think people find it easier to follow, but you have 3 things multiplied on this side. 5x log 3. If you want to isolate the x on this side, you can divide both sides by 5 and by log 3. Because then you end up with x is equal to that expression. If you don't like to divide by 5 log 3, you can divide by log 3 and then divide by 5 after it, right? If you're doing that on your calculator, you've got to watch using brackets on this expression on the bottom here. So we'll pull up this calculator. If you're trying to put that in, log of 600. Got to close the brackets on this calculator. I'm going to put another bracket here because we want to divide by this whole thing. 5. You don't have to put a times sign. It is 5 times log 3, but if you want on here, you can put 5 log 3. You need to put brackets around 5 log 3 because you want it to do that multiplication first. When you get a number, you should always check to make sure that it works. All right? So roughly, if we want 3 decimal places, 1.165. X is roughly 1.165. If you want to check that, quick way to check it on the calculator is store this as a variable. If you have, depending on what kind of calculator you have, almost all of them have a way of storing numbers. It just saves you from entering it in. You don't have to do that. I mean, you could just go back to the original equation, put the number in, right? 3 to the power of 5 times, I mean, you could put 1.16457 and check. It's going to be roughly 600. The more decimals you put in, the closer to 600 it's going to be. The calculator stores a phenomenal amount of decimals, even though it doesn't display it. Because when you put that, it's got lots of decimals stored. It shows that it's 600. Okay, so that's the way of checking that you're right. Now, hopefully you tried this one and discovered how it's different.